Have you ever wondered if science fiction's promise of freezing humans for future revival could actually become reality? The concept of cryonics, preserving human bodies at ultra-low temperatures with hopes of future resurrection, sounds like pure fantasy. Yet hundreds of people worldwide have already undergone this procedure after death. What seems impossible today might be tomorrow's medical breakthrough, challenging our fundamental understanding of life and death. The scientific foundation of cryonics rests on legitimate principles used in modern medicine. Hypothermic procedures already allow surgeons to stop patients' hearts for hours during complex operations, while organ transplant medicine relies heavily on preserving tissues at low temperatures. However, the vast difference between cooling living tissue temporarily and freezing an entire human body presents enormous challenges that current technology cannot overcome. Dr. James Bedford became the first person cryonically preserved in 1967, and his body remains frozen at the Alcor Life Extension Foundation in Arizona. Since then, approximately 500 people have been cryopreserved worldwide, with thousands more signed up for the procedure. These early adopters paid between $30,000 to $200,000, betting their life savings on improving science and future technological advances. The primary obstacle facing cryonics involves ice crystal formation during the freezing process. When water in human cells freezes, it expands and forms sharp crystals that puncture cell membranes and destroy delicate structures. Modern cryonics facilities attempt to solve this problem using vitrification, replacing blood with antifreeze-like chemicals called cryoprotectants to prevent ice formation. Vitrification successfully preserves small organs and tissues, with laboratories routinely storing kidney slices, heart valves, and even entire rabbit kidneys for later transplantation. The process transforms water into a glass-like solid state without forming damaging ice crystals. However, scaling this technique to preserve an entire human brain, let alone a complete body, remains far beyond current capabilities. The human brain presents the greatest challenge for cryonic preservation due to its incredible complexity and delicate neural networks. Neuroscientists estimate that the brain contains approximately 86 billion neurons connected by trillions of synapses, creating our memories, personality, and consciousness. Even minor damage to these connections could fundamentally alter or destroy the person's identity upon revival. Recent advances in cryobiology offer glimpses of hope for future success. Scientists have successfully vitrified and revived simple organisms like tardigrades and certain types of worms after decades of frozen storage. Additionally, researchers have preserved and transplanted lab-grown organs, demonstrating that complex biological structures can survive cryonic processes under specific conditions. The revival process poses equally daunting challenges, requiring technologies that don't currently exist. Scientists would need to repair cellular damage, remove toxic cryoprotectants, restore blood circulation, and restart all biological processes simultaneously. Current estimates suggest this level of medical nanotechnology might not be available for 50 to 100 years, if ever. Legal and ethical questions surrounding cryonics add another layer of complexity to the scientific challenges. Courts must determine when cryonically preserved individuals are legally dead, while families wrestle with inheritance issues and emotional closure. Some bioethicists argue that cryonics exploits people's fear of death, selling false hope based on unproven science. While frozen humans remain scientifically possible in theory, the practical reality suggests current cryonics procedures likely cause irreversible damage to preserved bodies. However, rapid advances in biotechnology, artificial intelligence, and nanotechnology could potentially solve these problems within the next century. Whether you view cryonics as humanity's greatest gamble or its most ambitious scientific endeavor, it represents our eternal struggle against mortality and our hope for a second chance at life.
Thank you for watching. Please like and subscribe.